Right, I thought I would record me developing this static queue because sometimes it's useful to sort of hear aloud the way my brain is working. And anyway, here we go. So I want to design a static queue, and of course, just to remind you what we need by static is that the data structure doesn't change size. So we're going to try and we're not going to cheat, we're not going to reduce the size of the data structure or increase it as we're using our queue. And of course, we're going to use object-oriented programming. Now, it's important to remember that you're going to need to understand the queue as a sort of conceptual idea, not just think of it as a programming task that is object-oriented. But the best way to implement a static queue is in an object-oriented fashion, because we can utilize this list. Otherwise, we're going to have to construct our own method of creating some sort of weird sort of memory management for the queue, which is a bit crazy. So you're not going to do that. And anyway, questions that you have in the exam on queues are most of the time they're going to be static queues, and they're going to ask you questions basically on your understanding of how the static queue works. And in particular, they're interested in whether or not you understand how to push, pop, and peek a queue. And there might also be some practical uses of a queue. And as you will see when we go through the course, we will continuously, that's ridiculous, but we will regularly use queue data structures for other algorithms that we're going to come across. So it is important. Okay, so here we go. We're going to create this new class. So class, and we're going to call it static queue, and we're going to descend this with an object. We descend from object in Python 3 because it gives us the opportunity to override certain methods. So if I control click this object class, you'll see in here that it gives us the opportunity to override all sorts of different attributes. And we've talked about this before, like the str method and the ge method, which is greater than equal to greater than. So you could think of implementing these, but we're likely to only override the str method. Whenever you create a class, the first thing you think of is the constructor. So let's do that first of all. So we're going to have def underscore init in the usual way. And then first parameter is always self. And now we're going to think about what parameters we might have. Now, I've got a static queue, and it's not going to change size, so I need to know what the size of the queue is going to be. So let's just call that parameter size. And because I'm going to have a list as a private property to store the information that's in the queue, the items, if you like, in the queue, or the elements, I'm going to create that private property. So let's say self.__, and let's call it items in this case. And we're going to set that to be an empty list to start with. And then we're going to fill this empty list with nons. In other words, we're going to create the storage space for our list. Now, you could actually, to a certain extent, say, hang on a minute, we're starting off with this empty data structure and we're changing its size. Well, if we're using a list, that's very difficult not to do that. We've got to start somewhere. So we're sort of allowing ourselves to do that. But as soon as the list is constructed, we're not going to be changing the size of it. Okay, so let's have a look. We need a for loop to fill these now. So we're going to say for I in range and size. And we're simply going to append this list with nons. So we're going to self.items append non. Now that means that we're going to literally have an array that looks something like this. So, non, and it's going to go up to however many elements that we've got in there according to this parameter size. Okay, so what else do we need? Well, we might need to keep track of how many elements there are in the queue, because we need to figure out whether or not we can push something onto the queue and whether we can pop it. So let's have a look at self.size is equal to size. So we maintain this size here. Because this is just a local parameter to this constructor, if I don't have a class property called size, I'm going to lose this size parameter as soon as I'm not in the constructor anymore. Probably even want to make it private, so you don't want to be able to access that. In which case, we need perhaps a getter for it. We might want to, somewhere outside of this class, ask how many people are in the queue. Some sort of application for a shop, and it's modeling the queue in a shop. We might want to ask how many people are in the queue. So let's have a getter for that. So we have get size, and that's going to return this private property. Okay, so that's constructed the queue, and now we're going to be able to add elements to the queue with push, or actually not push, but enqueue, E-N-Q-U-E. So that's adding to the queue, and we're going to leave the queue with a method called dequeue, and they're typically the words that people use in your exams. So def queue, and if we're adding something to the queue, we need to know what we're adding. So we just call it an object. And notice that I'm making this fairly general, so we can, in the same way as we have our stack, we're just being able to add any old thing to the queue. If this object could be of any type, it could be an integer, a string, it could be an exercise book like we've been doing in class, whatever. So first of all, if I'm going to add something to the queue, I've got to make sure it's not already full. So I don't have a method which tells us whether it's full at the moment, so let's create one. So def is full, and that's going to return whether or not the current size is equal to the length of this list. So return, no, I beg your pardon. So that's not right at all. What we've got to do is have a pointer to the front of the queue and the back of the queue. Hang on, let's just get this right. This size is how big the queue is all of the time. Okay, whereas the current size is how many objects are in the queue. Because remember, we've got our queue. Okay, it looks something like that. Non. Let's say there are 5 elements in there. The size is 5 because there are 5 buckets sitting there waiting for things to be in the queue. 5 places in the queue. But there's nothing in there. So we need, the size is fixed. That's 5 in this case. But the current size, or the number of elements that are in there, changes. Okay. So for example, if there was, let's say, in the front of the queue was David there as a string, then that obviously would contain 1 item. So we need to maintain that size. And we could have that as perhaps number of items or something like that. So let's do that. So we're going to say self dot number of items in queue. I know that's a long variable name, but at least it tells us what it is. Currently, there's nobody in there. It's all none. So in the constructor, we're going to set that as 0. And the get size is going to be returning that private property, which is the number of items in the queue. We need to make sure we maintain that. So if it's full, then the number of items in the queue is going to be equal to the original size. So that's going to be returning self dot underscore number of items in the queue is equal to self dot size. Okay, so if these two are equal, then this will return true. If they're not, false. So if we're adding something to the queue now, we first of all want to determine that it's not full. So we can say if not is full, and that's referring to this function which is encapsulated within the class in itself dot is full. Then if it's not full, we can add something. So what do we do? So we're going to add an object. So let's have a think about the situation that we're in. Just put this as a comment. So again, let's say, imagine we've got somebody at the queue, and then maybe the rest are just normal. Like that. Okay. Now, if somebody comes along, this is going to be where they're pointing. This is where we're going to add them. Okay. Now, we've got no way at the moment of knowing where that is. I suppose we could use the size of the queue. So here, the size of the queue is 1. The index is 0. If there was somebody here as well, somebody called James was in here, then size of the queue 2, or the number of items in the queue, should I say, is 2, and the index of the back of the queue is 0. But much better is to actually keep track of which index, in this case 0, is the front of the queue. So David is at the front of the queue, so his index is 0. And James is at the back of the queue, and his index is 1. So we're going to have two other pointers where the front of the queue and the back of the queue are going to keep track of where the front and the back are. Now, if the queue is empty, remember that the pointers are going to, the indices of the pointers are going to be 0, 1, 2, 3, 4, etc. So let's say that we're going to have -1 as meaning there is no front and back. So we're going to have self.front pointer, and that's going to be -1, and self.back pointer. That's also going to be -1. In other words, so index of -1. Okay, that's what like that. Little comment in there for another programmer reading our code. They might think, what do you mean -1? Don't get it. Well, that little comment tells them. All right, so let's go back to our situation where we've got this queue. Imagine that the situation is that this is going to be, if you like, here. This is our front, and this is our back. Comment in here. This is our front, and this is our back. Then somebody joining the queue is going to be joining at the position 1 after the back, and we know that there's room for them because we've said if not self is full. So there's definitely room. So what do? Well, we move the back pointer from where it is to this next position in the queue. So that's the first thing we're going to do. So we're going to say self.back pointer is equal to self.back pointer plus 1. So that has the effect of turning, copy that. That basically has this effect of putting the back to here, there, and then we are going to fill in this object at this place here. So we're going to say self dot and then underscore, and then the list, which is the items, and then the index is going to be back, self back pointer becomes equal to an object. Okay, so we're assigning this object to live in this item at this position here, where there is currently a none, and there won't be a none there anymore, because whatever an object is, that's what that's going to be. Okay, so basically our list now is going to look something like this. David's obviously still at the front of the queue. James is behind David, and then whatever an object is here. I don't know what it is. It might be a string, it might not be a string. It's going to sit there, and we're going to have our non here. So that's the sort of idea. I'll obviously put a lot of comments in here so that you can follow. So we've basically shifted the back pointer, and once we've done that, we know we've successfully added something to the queue. So the best thing is to update the size property. Otherwise, it's going to get out of sync. So we're going to have self dot underscore size equal to self dot underscore size plus 1. Now, if it wasn't full, so if it's not full, if it was full, else we know that the queue is full. So we might just print a message here to say cannot enqueue the object since the queue is full. Okay. We'll look at that later. We've talked a bit about sort of just printing messages. There is probably a better way of dealing with this with just printing a message, but I will explain that at another point. Okay, we're hopefully that is okay. We could test that now. So we go back here onto the main line of the code. Let's create ourselves a queue. So my queue equals, what do we call the object? We call it static queue. Oops, static queue. And it requires a size, and let's just put a size of 2 just to make testing a little bit quicker at this stage. So my queue dot enqueue, let's enqueue David, like we said we did in our examples, and my queue dot enqueue James, and then my queue dot enqueue. Let's try and add somebody else now. Let's try and add Fred, and we should, all being well, have a message that's saying cannot enqueue Fred. Or, well, cannot enqueue the object at least. Oh, list index out of bounds. What's going on here? Ooh. Okay, let's figure this out. Back pointer. Back pointer is strange. This is normal process. This is the advantage of me recording all this stuff. You can see what happens if it goes wrong. Let's put a debug breakpoint on there. That's where it's going wrong. Debug. Oh gosh, what's this? Allow. What? Windows Defender? What on earth's going on? No. Oh god. Oh, there I come. Oh dear, let's try this. Okay. Seems as though I've got access to that. Strange. Anyway, ignore that. So let's see what's going on here. So look, what is back pointer? Self. Back point is 0. And where's my items? Self.items. 0 and 1. Length is 2. That seems okay. So self.item 0 seems okay. Okay, self.size, which is 2. Not size. Not size. I knew I'd fall into that. It's the number of items in queue, not size. Hopefully you will realize that. I knew I shouldn't have called this size and number of items in queue. Size is much nicer variable for the actual size rather than its initial sort of number of buckets. Okay, so thank you, breakpoint. That was very useful. Let's just stop that. And this should not be increasing the size. This should be the number of items in the queue. Oops. Number of items in queue. Number of items in queue plus 1. That's better. Right, let's try again. Run it. Cannot enqueue an object since the queue is full. That's what we were expecting after I had 2. It would be nice to print this queue, wouldn't it? So let's add a override our __str method, which enables us to print the queue in a nice way. So let's do that. So let's have a return string equals. Now we want the front of the queue. So let's just add a string that points to the front, like that. Then we're going to say return string equals what it already is. And we're going to go through our list now. So we need a for loop here. So for item in self items, like that. So that's a for loop that's going through each item. And then we're going to indent this with a tab. Plus, and then we're going to say str item. Now, just to sort of say, where's that gone? That requires that each item in the queue has the ability to turn itself into a string. If we're storing objects such as exercise books or something more complicated, then those objects would need to know how to render themselves as a string. So they would need their __str methods implemented in order for this to work. But at the moment, I'm only adding strings to there, so quite clearly strings know how to render themselves as strings. After I've added all of the items to the queue, I might want to also add some sort of comma here. And after I've done that, I'm going to say return string equals return string plus, and then I want to say that this is that, like that. You see how that works? Oh, I've got to return that return string now. Otherwise, it will be returning none, and it would cut. In fact, let's show you that. Let's go here, and at this point, let's say print my queue, and it will print a none here. Oh, it can't. It's a type error. __str returned non-string type. Non-type is actually a type in itself. Notice it's returning none here because I'm not returning anything, which is what I just said would happen. Return string. There we go. Okay, so here's it's a bit messy. Front David. Oh, let's put a space there, and maybe a colon, and then maybe a colon here, and then back. Let's look at that. That looks a bit better. So we've got David James. We've got this trailing comma at the moment here. Bit messy, but let's say we don't care about that at the moment. We can sort that out later. And let's try my queue again at the end. It should be the same because there's no room for poor old Fred in the queue, so everything's fine. Good, so far we're happy. Now, what can we do next? We've got NQ, and let's try writing a DQ. FDQ. We probably want our DQ method to return to the person who's calling DQ the actual object that was on the queue when they're asking for DQ. So we're going to write a function that returns what's at the front of the queue. Okay, so let's have a look. So let's think about, in general, dequeuing a queue. First of all, we've got to make sure that there's something in the queue. So let's do that. So if self dot is, now we need empty is empty. So let's write is empty. We've got is full. We've got def is empty. And we're going to return self dot number of items in queue is 0. Do you agree? If it's the number of items in the queue is 0, then this would return true. So therefore is empty would return true. So if self dot is empty, then we're going to print a message to say cannot dequeue an empty queue. Else, let's actually dequeue this now. So let's take some temporary variable to be whatever at the front. Oh, that's just peak. Maybe we need a peak method. That would be nice. Def peak. Okay, so if the queue is empty, then peak is going to be none. So let's do that. So if self dot is empty, then not is, if self dot is empty, return none. Else, notice it's best to return none rather than print a message, because if you just print a message, peak isn't returning anything. We're better off returning none so people can check to see whether it returns none and therefore figure out that it's actually empty. So otherwise, we're going to return whatever is at the front, which is going to be the list, which is the items, and that is going to be the front pointer. So that's going to be the front item. We'll talk about that in a minute. Another thing that we could think about is the fact that in a queue, should the front always be the 0th item? Imagine we're going to this queue up here. My mouse is wiggling around. Maybe the front should always be this item here. And when somebody leaves the queue, all these guys need to move up. Move up one. Like they would in a real queue. Somebody's in the queue and they get served. James thinks, oh, then it's my turn next. So they move up, and then this guy moves up, and this guy moves up. And maybe we need to do that with DQ suddenly. Okay. We need to think about that. In which case, if that's the case, then we can set the front point. Rather than using front pointer, we might think that that should always be 0. We'll think about that later, and there's a good reason why I'm saying that, because there's another data structure that we'll need to study that doesn't do that, doesn't force everyone to shift up in the queue. And you can imagine if we've got a queue that's 1 million items in it, if somebody leaves the queue, then we've got 999,999 moves, people moving up in the queue. It's perfectly reasonable that in the day we've got huge amounts of data, that we might have 1 million people in the queue, and therefore it does seem quite expensive. But we'll deal with that later. At the moment, we're going to assume that everyone does shift up. Right, okay. So else. Okay, so what we're going to do, a little comment here. We're going to say person at front moves out of the queue. Maybe they're served, if you like, which gets returned. Everyone moves up in the queue by one place. Right, okay, nice little comment there that sort of explains what's going on. Right, so let's get our person at the front. So person at front, that's the peak. Self.peak. Let's got hold of that so that we don't lose them. This that's David, if you like. And now we're going to want to shift everybody up one by one by one. So how are we going to do that? Well, let's think. Let's say we're looking here. Well, this person overrides that, and then this person overrides that, and this person overrides that. So we need some sort of for loop now. Okay, so we're going to have a for loop to shift everybody up. Let's say do shift up one place. Okay, so we're going to say for I in range. We're going to go from the front to the back pointer. Okay, so we're going to say from self dot front pointer to self dot back pointer, and that's obviously in steps of one. So why are we doing that? Well, if you think there's no point shifting these nons up because they're going to be nons anyway. Imagine we had 3 people in the queue, but the size of the queue is 1,000. There's no point shifting 997 nons. There's just no point. We only need to shift these people up to that. Okay. So what happens? Well, the ith person, the ith place in the list is going to be filled with the I plus 1th person in the list. Okay. Now we've got to make sure that the I plus 1th person in the list doesn't go off the end. So if the queue was full when people was dequeuing, we don't want to shift that last. We can't shift this last person. There's nobody to fill their place. We actually want to go one less than the end of the queue. And now we're going to say self dot items I becomes equal to self dot items I plus 1. Okay, so this is the person after them. The person in front, the place in front of them in the queue is going to be placed with this person here. But I plus 1 could go off the end of the list, which is why we do this back pointer minus 1 to make sure that doesn't happen. Anyway, we can debug that and show you that working later. Is there anything else that we need to do? Oh yes, after we've done that, we need to make sure that the size decreases, or not the size, sorry, the number of items in the queue. I'm going to make that mistake again. So self dot number of items in the queue is decremented. So self dot number of items in queue minus 1. By the way, many programming languages have this sort of shortcut method, say minus equals 1. But I'm not going to do that. I'm going to stick to this notation so that you can go to any programming language. Some people some programming languages has a decrement function, for example, DEC, some of them. Let's just stick to that for now. Okay, so the front is staying the same, but the back now, remember, because this David has left the queue, they've been dequeued. All of these people have shifted up one. So that means the back pointer is one less than it was. I actually have to shift the back pointer as well. So here we go, self dot back pointer. This one. Notice the generous use of the tab key here. So when I say self dot, I know it's back underscore back pointer, but it's nice. I can just do back pointer, and there it is. Press tab, and there it goes. -1. Hopefully this is going to work. Let's see. Let's see. Right. Let's move enqueuing and let's dequeue. Now my queue.dequeue, and I could call this, because this returns, it doesn't at the moment. It's supposed to return the person. Notice that this is grey, which means it's not being used. That's because I haven't returned this yet. So I'm going to actually return this person in front I saved earlier. Now I'm going to say front person, calling it a different variable just so that you can see that this is a variable in my main line as opposed to the value that I'm returning up there. So front person is that, and then I could say a message to say print front person. Let's do that as a string, str, front person, plus, and then a little message as left key. Print the key. So what we're hoping is we've got David and James in the queue. We know that works. We're going to get front person, which will be David. So it should say David has left the queue. And then when we print this, James should have moved up into the front of the queue, and there should be none straight after it. Let's see if it works. What's the chances it works? Oh, almost. So, oh, James has left the queue. That doesn't seem right. Let's go back. So, person at front pointer. Okay, it needs a breakpoint. Let's have a look. So I'm putting a breakpoint after we dequeue. Let's see what happens. That's the enqueue. Remove that breakpoint. That works. So let's have a look. So our current queue looks like this: David, James. Oh, is that right? David first? Yes, David, James. That's right. Okay. Person at front. Step over that. Person at front. That's not right. Person at front is James. No. David was at the front. Thank you very much. So this peak is wrong. Let's have a look. Self.front -1. Why is the front pointer -1? NQ. NQ doesn't set the front pointer. Somebody's joined the queue, and I forgot to set the front pointer. So in actual fact, NQ didn't work properly. Okay, this is cool. Let's fix that. So when we NQ, we need to set the front pointer as well as the back pointer. So the back pointer is back pointer +1, and join the back of the queue. But we want to set the front pointer if the queue was empty. Right. Okay. So here we want to say something like, if the queue is empty, set the front pointer to be 0, or increase it. Front pointer accordingly. Okay, so if self is empty, self.front pointer equals self.front pointer -1. Now, because I know if it's empty, it's -1, I could have just set it to 0 here. It makes more sense to read it to say the front pointer is increasing. It was -1, now it's going to be 0. Hopefully that will work now. Let's just run again, see if that fixes stuff. Okay, David has left. Okay, we're getting there now. So we've got David and James in the queue. David has left the queue, but no, David's still there. That's not right. And not only that, but these guys haven't jumped up, so it's not working at all. Let's carry on. Let's go to debugging here. I first of all want to make sure that this enqueue is actually working. So I'm going to put a breakpoint in my enqueue again. And I'm going to debug. Right, so we're enqueuing. If self.is full, that should return false, which it does. Sorry, if not is full, return is full is false, and not if false is true. So if self.is empty, it is. So, is that going to return? Hopefully, the number of items is 0. Yeah, so that's going to be true. That's true. So self.front pointer, which is currently -1, that's right, it's going to increase to 0. So the front pointer is 0. And the back pointer, which is currently -1, should also be increased to 0. So both the front and back are pointing to 0. That should be correct because David's the only person in the queue. So the front and back are both pointing at 0, which is David. That's correct. Now self.items, the back pointer 0 becomes an object, which is David. So the 0th item becomes David. So that's correct. David is joining the queue. And the number of items in queue, which is currently 0, will go up to 1. Okay. Now let's go again. So let's step into the queue here. Is the queue full? No, there's only David in the queue at the moment. So is it empty? No, so we don't change the front pointer, which is correct. The back pointer is now going to be increased to 1, which is correct. 0, 1, none. So the back pointer, which is 1, becomes an object, which is James. So this none here should now change to James, which it does. So the back pointer is 1, which is correct, 0, 1. And the front pointer is 0, which is correct, 0, 1. And now the number of items in the queue, which is currently 1, should go up to 2. Happy with that. That does seem to be working. Now, this bit's going on now. So we're going to dequeue the queue. So let's step into there. Right, is the queue empty? No. It isn't. So person at the front is self.peak. Let's see if that works. Let's step into there. If self is empty, that's false. So we should return the front pointer, which is 0, which is correct. So that should return the person at the front. So that should return David. The person at the front is David. That's correct. Right. So now we're going to go from 0 to 1 minus 1. 1 minus 1 is 0. It's always 1 less than that. Remember, in a range for a for loop, there's always 1 less than this. So it's actually not back pointer minus 1. It's back pointer. Let's go over that again. Remember, a range function is always 1 less than this end point. And the end point we actually want to be not 0 but 1. know of one error at the moment. I'll tell you about that in a second. Let's run it, see what happens. I'm expecting James. That's perfect. Right. So David left. But what I didn't do when David left in the DQ method is to make this none. Or to make this one none, should I say. Because these guys all move up. But the person at the back of the queue should be none. Let's have a look. When we DQ, what we've got the person at the front, that's fine. But what I want to do is that the person at the back becomes none. So let's fix that. So self dot items self dot back pointer is equal to none. Basically, this is person in the back. I can't do that yet. That means this needs to happen later. Just there before we reduce the back pointer. In other words, what I'm thinking of is David's leaving, right? So David leaves. James gets copied into there, but this still says James. So I need to make this none. So that's where the back pointer was. This now becomes none. That's what I've just done there. Then I reduce the back pointer. Okay, let's see if that works. Yeah, there we go. So we have David, James. David is left in the queue. Now we've got James. None. Starting to look good. Let's try something else. Let's increase the size of that 3. And let's go again. And there we go. David and James. James left. None. Good. And let's, after we've DQ'd, we should now perhaps try and kill someone else. And David, James, Fred. And let's print the queue. Here we go. David, James, none. David left the queue, so we've got James, none. And Fred joined, so now we've got James, Fred, none. This is all looking cool. Now let's DQ again. Now let's NQ until it's full. No, we tested that at the start. That's fine. Let's DQ and DQ again. And DQ again. Let's put it back. Let's print this DQ plus left the queue. I'll do that again. String DQ plus consistent. Put a space there because I don't want it to say David has left the queue without a space after David. So remember, David and James are joining. Here I'm doing this slightly differently. I'm actually holding on to the person. Here I'm printing the person who left without creating a variable. That's all fine. David and James, and then David leaves, leaving just James. Fred comes on, so we've got James and Fred. And then James and Fred are both going to leave, so it should be an empty queue. 3 people. David and James. David left, leaving James. Fred joins. James has left, so just leaving Fred. And now Fred leaves, so left the queue is empty. That's nice. what might be nice when we print the queue is we could say like this: if self is empty, we could say return string, return string plus space queue is empty. And we could say if is full, return string plus queue is now full. It could be full and empty at the same time if we create a queue with size 0, which would be a bit stupid, but we could do that. Both full and empty at the same time. But anyway. Okay, that's nice. Queue is now empty. There we go. And if, let's say, somebody else joins here, queue. So after that, it should be full, which it is. David, James, and George. Queue's now full. That's good. James left. Fred joins. It's full again. James left. George left. Just leaving Fred. Let's just keep dequeuing here. Let's do another one of those. Should be empty now. Empty. Yes, good. And let's try and dequeue again. It should say it can't leave the queue. It's not. There's nobody in it. Yes, we did. Yes, cannot dequeue. Queue. Good. None has left the queue. Fine. And there we go. Everything's cool, I think. Hopefully that will help. Sorry it's a long video. But you got how my mind works. Which is never a good idea. Cheerio.